Okay, so today we're going over Module 11 again. So it's the corresponding parts of similar figures. And again, so the objective is still what is the relationship between sides and angles of two similar figures. So we're going to start off with what are similar figures. So we just say two figures are similar if these two conditions are met. First one says corresponding sides are proportional and corresponding angles are congruent. So long as those two things are met, the two figures are similar. Okay, so next thing says, what is one additional piece of information needed for the two triangles to be similar? So in this case, okay, so you see this side and this side are both missing. So these two sides correspond to each other. So what we need to know is that CB over FE is equal to 3/1, and that's also equal to 6/2. Or the information we need to know this. We need to say that CB over FE is equal to, so 3/1 or 6/2, think of it as equals to 3. Or think of this as your scale factor. Right? Example 3 says what must be the length of AT for the figures to be similar. So AT right here is missing, so I'm going to call that X. Okay. So here I know that 4 goes with the X, which means that this 2 goes with the 4, and this 3 corresponds with the 6. So the way we set up our problem here, we say 4 over X, because these two correspond to each other, equals, and here we just pick one more pair. So I'm just going to say 2/4. Okay, so once we pick those two, then we just solve for X, or the missing side. So here we cross multiply. So X times 2 gives me 2X. And then 4 times 4 gives me 16. Divide this by 2. So I'm going to say X equals 8. Or more specifically, we say AT equals 8. Okay, number 4 says, what must be the length of AC for the triangles to be similar? Okay, so if I'm putting these together, I know 3 and 6 correspond. This 2 and this 4 corresponds. So that means that this value here, AC, goes with the 8 right here. So I'm just going to call this side X, since I don't know what that is. So I'm going to start off by putting X over 8. And I'm just going to pick 2 other sides. So I'm going to say 3/6. Okay, so X times 6 gives me 6X. 8 times 3 is 24. So you just multiply these two, and I'll cross multiply with these two. Now divide this by 6. X equals 4. Or actually, not x equals 4, but we're going to actually say AC equals 4. Okay, 5. Again, what must the length of AC for the triangles to be similar? Okay, so in this case, so I know side BC and side EF, they correspond. So that means that this side here, AC, which is going to call it X, because I don't know what that is, corresponds with 3. So when I set my formula up here, for proportion, I'm going to say X over 3 equals 9 over 5. And I just cross multiply from here. So X times 5 gives me 5X. 9 times 3 gives me 27. Okay, so now I just divide both sides by 5. And now X equals 27 over 5. Since this cannot be reduced, we just leave it as a fraction. So I'm just going to say side AC is equal to 27 over 5. Okay, so on the bottom it says, what is the scale factor for the two triangles below? Okay, so this is what we have here. So we have two triangles. We have this small triangle right here. So I'm just going to redraw here. So that's LVT. So this is side 3. And then if you look at the bigger triangle, which is this one right here, so if I were to draw that bigger triangle here, the side, this is M, N, and L. You see that this whole length here is 3 and 6, which gives me 9. So this is 9 right here. Okay, so the scale factor here. Okay, the way you figure out what the scale factor is, you have to figure out what triangle we're going from one to the other. So here we're going from here to here. Okay, so the triangle is getting bigger. So the way we set up our proportion here is I'm going to start off by putting ln over lv. So you always start off by putting here where you start on the bottom and then where you end on the top. So we ended at 9, so I put a 9, and then we started at the 3, so it's 9 over 3, And then 9 divided by 3 is 3. So this 3 right here, that's my scale factor. Okay, so the triangles below are similar. Complete the ratio. Okay. Okay, so far we know that A, B, and D, E are proportional. So AB is this one, DE is right here. Okay, so now I pick another side. Let's say BC goes to EF. So on top, BC over EF. Okay, which means the last side, FD and CA go together. So I put equals, then I put the bigger triangle on top, so it's going to be CA, and then FD. Okay, and that's essentially what you need here. So this is our answer right there. Okay, so on this next part, it says angle-angle similarity. So here we have the two triangles have corresponding angles congruent, then the triangles are similar by angle similarity. So all you need here is just two angles congruent. So you see that this one and this one, that's the first angle. And this one right over here, and this one over here, the second angle. So if they're congruent, if they have two angles congruent, we say they're similar. So that means we would write down, start like this. So you say triangle ABC similar to triangle DEF by similarity. Okay, so next one, example 8. So you figure out, do they have angle, are they similar? So if you notice angle A and angle Y, so here we say angle A is congruent to angle Y. And you look at B and Z. So angle B is congruent to angle Z. So here we have an angle. So here we're going to say triangle ABC, similar to triangle YZX. And we say by angle similarity. Okay. Example 9. So we're saying the two triangles similar. So far they only give us one angle common. So here we say angle E congruent to angle L. So that's our first angle. Okay, now the way we figure out the other angle So just solve for, so there we just say 102 minus 30. That's 72. And then 180 minus 72, that's equal to 48 degrees. So this is 48 degrees. And now, knowing that, now we know that angle G and angle N are congruent. So we say angle G is congruent to angle N. So we have our second angle. So here we would just say now triangle EGF is sorry is similar to triangle LNM by angle similarity. Okay, example 10. This time are the angles similar. So far they have one angle in common. So we're going to say angle B is congruent to angle E. So that's our first angle. So let's just solve for the second angle right there. I'll take 81 So I'm going to take 81 plus 60, and that gives us 141. And then 180 minus 141, that gives us 39. So that means that this angle here is 39 degrees. Which means that this angle over here is 59 degrees. So none of the other angles are congruent. So we say the triangles are not similar since corresponding angles are not congruent. Okay, I believe I forgot. All right, go back to example 1 and get practice to do this one. Okay, so when it says here similarity statements, that's all you need to do here. So the triangles are similar, so we know angle A and D correspond to each other. So we're going to say here angle A is congruent to angle D. Okay, I know angle B and E corresponds. I'm going to say angle B congruent to angle E. And then the last one, angle C and F correspond. I'm going to say angle C congruent to angle F. Now look at the sides. So let's say first on BC, that corresponds to EF. So I'm going to say here BC over EF. Okay, which means the next one would be these two sides right here. So I'm going to put CA, right, equals, corresponds to FB. And then last side, these two are here. So I'm going to say AB and DE correspond. So all of these so this right here are my similarity statements. So now I just write down a triangle ABC similar to triangle DEF. All right, let's get into the last two examples. So center of a dilation. So again, remember A and A correspond. B and B correspond. And then C and C prime correspond. So the way you find the center is just connect the corresponding sides of a straight line. So I'll connect A and C together, B and B together, and C prime and C together. And where all three of them meet, that's my center. So I'm going to say that this point right here is my center of dilation. And then last example, again here. So I'm going to say that so this point, that point corresponds. This point and that point corresponds. And then this point and that point corresponds. So I'm just going to connect them. So right there, and right there. So it means that the center, so this right here, and then the point right there would be at 5, -7. Okay, so we're done with today's notes.